1.7 is modeling with equations. This is one that people generally have problems with because, in general, high school kids struggle a little bit with modeling things where normally they're used to plugging and chugging and evaluating equations, but not applying it to real life. So in this case, we're trying to apply it to real life. So um, here are some guidelines which I find are helpful. Identify the variable, translate into algebra, set up a model, and then solve, obviously, and check. So let's just go through a couple of problems here. Number one, rental car company charges 30 bucks a day and 15 cents a mile. Well, you need to think about which things are set prices and which basically build off the fact that, in this case, how much you're using essentially the car. So in this case, the $30 a day is basically what you are charged, regardless of how much you use it or don't use it. 15 cents a mile is essentially um, how much you're charged per mile of driving. So the more you drive it, the more you're going to pay. The less you drive it, the less you're going to pay, things like that. So when that happens, your 15 cents essentially needs to add on to a variable. Well, you need to be careful here. So X is going to end up being the number of miles. Okay, so when you drive, I don't know, let's say 100 miles, it's going to be 100 times 15 cents. Well, be careful here. I don't like the fact that they said one is cents and one is dollars. You essentially need to convert, so make sure that it's 0.15x. And then lastly, it says that your bill is 108 bucks. Well, if it's 108, I would love to rent a car for 108 bucks. I don't think that's super realistic, but we'll do it anyway. Now that we have this, that's enough, okay? And I'm not going to solve all these for you because I think you know how to do that. But essentially what you're looking for is you're looking for the thing that's basically per mile, and that's the one that's attached to the variable. In this case, this is a little bit tougher of a problem. Mary inherits 100 grand. Glad to be Mary, obviously, and invested in two certificates of deposit. Those are just called CDs, which, since the housing crisis, don't have the same value that I guess they used to. They used to pay out a decent amount. Now they don't. Not that you care. One pays out 6%, the other 4.5%. Well, if you do that and you know that, I don't know why you wouldn't put it all in 6%, but regardless, here's the problem. So essentially what we're trying to do is we're going to have two sets of money. It says that we're basically investing all of our money in the 100 grand. So half and half or 2/3 and 1/3 or whatever it is. So we know all the money is going in there. Some of it is attached to the 6% and some of it's attached to the 4.5%. Hopefully more of it's attached to the 6 than the 4.5. But once you have this, now we're solving a system of equations, okay? And I'll just give you a quick heads up on this. I would probably solve it as just saying X is equal to 100 grand minus Y. And then just take that 100 grand minus Y and plug it in for X in your other equation. And then you have Y's all over the place. And I know we've worked on those, so that should be decent for you, but it's again a realistic problem. And then the last one is a square garden. And this is a realistic problem, I guess. Putting a border around the garden, you're obviously wasting some area. It says that the entire garden, including the walkway, is 18,000 square feet. Well, if it's 18,000 square feet, I know that's the entire B times H there. Well, if you know that X is just the area of the garden, you're going to add 3 to both sides. So X plus 6 is essentially the height of the garden. If you're looking at it from the sky or whatever. And then if it's a square, I believe it tells us somewhere here, yep, it's a square. So the other part's X plus 6 as well. So X plus 6 squared is the area there, and then you just solve. So not too bad. So hopefully you guys can follow those guidelines. Make sure you check your answer at the end because at times you do get extraneous solutions. That's it.